Hello everyone, welcome to the continuation of today's notes. So in class we started 2.1 power and radical function notes. We did 1A together. I know most of you probably already have this in your notes, but just in case you're missing any details, I wanted to include it. So now that you have seen 1A, go ahead and try 1B for homework. And we're going to pick up our notes with 2A. So the function for 2A is negative 1/2 x raised to the negative 4th power. If you're just getting used to your graphing calculator, in that y1 spot, once you hit the y equals tab in the upper left hand corner, you're going to type, I always like to include a parenthesis, that's just me though, negative 1/2 x, that's not the times button, okay, remember that's the x variable button, raised to the negative 4th power, and hit graph. When you do, you should see a graph that looks like this. Oh, sorry, pen's acting up. And remember, always adjust your window if you're not seeing it like you need to. That should be symmetrical. I know mine's a little off, but good enough. Okay? So let's analyze this graph. My domain. So here I am coming from my smallest values. Have a graph, have a graph, have a graph. Oh, no graph. And then the graph picks up again. So what x value is this graph avoiding? 0. So my domain, I go from negative infinity to 0, jump 0, and then pick it back up again, 0 to infinity. Remember, domain are our x values. So I looked along the x-axis, the graph exists, does not exist. And then, look at that, exists again. Okay? Range, let's start from our smallest y values. We have a graph, have a graph, yes, and stop. So once we get to 0, the graph never touches 0, and then above 0, no graph, which means my range is negative infinity to 0, both parentheses. Intercepts. I have asymptotes on the x and y axes. So if you want to draw those in as dotted lines, feel free. What that means is, does this graph ever cross the x or y axis? No. Right? There are none, or if you prefer, does not exist. End behavior. So this is where we're going to use our limit notation. So first, let's take the limit, lim, as x gets really small. So as x approaches negative infinity, we're going to look at what our y values are doing. So here we go. Starting at 0, because remember 0 is neutral, I'm looking left. So as my x values get really small, what are my y values doing? And really, we're just looking at this piece of the graph right here. So as my x values are getting really small, my y values are getting closer and closer to what number? 0. So that equals 0. Next, let's look at our limit, or the behavior of the graph as my x values get really big, so to positive infinity, what are my y values doing? So again, you have your highlighter handy. As my x values are getting really big, what is the end behavior of my graph? What are my y values doing? Well, again, we're getting really close to 0, so that's the limit. Gets close to 0. Continuity. So we're looking for any holes or jumps over asymptotes in our graph, and we definitely have those. Remember, we're looking at our x values, our inputs. So here we're good. We jump 0, that's a discontinuity in our graph. So we have a discontinuity at x equals 0. Now, this is actually the formula of this vertical line. So if we want to make a note, x equals 0 is this asymptote right here. Okay, decreasing. So this time we're going to, again, go left to right. So left to right, decreasing. So that would be from negative infinity to what x value? So not negative infinity to positive infinity. From negative infinity to what x value? 0. Decreasing. Then increasing. Again, thinking x-axis. So 0, so we're increasing. 0 to infinity. And that is it for 2a. So go ahead and click pause and try 2b. Okay, last but not least, 3a. I have f of x equals 2x to the 3/4 power. So in our graphing calculator, y1 equals 2x, there it is, caret, raised to the 3/4 power. Go ahead and click on graph, see what you get. Your graph should look something like this. Okay, so go ahead and do a quick sketch. Let's analyze. Domain. What are my possible x values? So looking at the x-axis, there's no graph up until what value? 0. And then the graph goes to infinity. So my domain, 0 to infinity. Now, why is that a bracket? Well, that's because 0, 0 is a point on our graph. Next, range. This time looking at the y-axis. So I look at my negative y values. No graph, no graph, no graph. Where does my graph start in terms of the y value? Also at 0, and then it goes up, 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 up. So again, 0 to infinity. X and y intercept, shared. Intercept is at 0, 0. And we can make a note that's the x and y intercept. End behavior. So let's look at the limit. As x gets really big, so as x goes to positive infinity, what are my y values doing? So here it is, x is getting really big. As x is getting really big, my y values are also getting really big, so it's going to positive infinity. Now take a second and think, why am I not going to do the limit as x approaches negative infinity? Have an answer? Well, it's because if I look at where x is getting really small, there's no graph. There's no graph to examine, so this limit does not exist. We could just ignore it completely. Continuity. Where is it continuous? Well, here's my graph, 0 to infinity. In my graph, I see no holes or no asymptotes, so it is continuous on 0 to infinity. Increasing and decreasing. So reading our graph from left to right, it is increasing 0 to infinity. Is it decreasing anywhere? No. So none, or it does not exist. Okay. Now, tomorrow, just to give you a little preview, I'm going to be asking you a question that involves remembering that this exponent is power over root. So how could I write this function as a radical equation? That's my hint for tomorrow, where we're going to pick it up. Now you can do 3b as a homework question. And if you have any questions, let me know. Before I end this video, though, I did just notice that I put a bracket here. That should definitely be a parenthesis because 0 is neutral. So go ahead and fix that. If you already had that, awesome, good job. Remember, any questions, send me a message on Remind. Have a great night, guys.